Hello, in this video I will show you how to use the NACA profile generation function. Here I have opened a foil wing. We see the top view here in this panel. Here the cross sections, the frames, and there the side view. If we look at the 3D view, it is a pretty standard foil wing. On the middle slice, we want to generate a profile from a NACA formula. For that, we have the choice: either we go to the menu component, Slices, NACA Profile Generator. Or we use the right click in this panel, then we select Slices, NACA Profile Generator. Or, to go faster, we press the Shift key, and then, with the right click, we arrive directly in the Slices submenu, and we click on NACA Profile Generator. Here is the NACA Profile Generation window. The first field, here, corresponds to the thickness of the profile. We have it in absolute value or in percentage. Then, here, the value of the camber in absolute value or in percentage. The position of the max camber. Here, in percentage, 50 is in the middle. Here we have the thickness of the trailing edge that we will leave at 0 for now. Knowing that for NACA profiles, in any case, the trailing edge is never of 0 thickness. And here, we can add a tilt angle to the profile. This value takes by default the tilt angle of the slice that we chose. That is to say the angle between the left apex point, so the trailing edge, and the right apex point, the leading edge. Here, we will set it to 0. Now, I click on OK. There you go. Automatically, Shape 3D has added green guidelines, here, which correspond to the NACA profile. And adjusted the slice on these guidelines. We can see that it is not perfect. This is because the control point, here, is fixed vertically by the top curve, here. So the fit can't be perfect. But what we can do is unedit the top curve in the side view. In the curve list, I right-click to unedit the curve. OK. We can see that the top curve here no longer has any control points. The thickness of the foil is now determined by the interpolation between the slices along the x-axis. This control point is then free vertically. I do Shift plus right-click again to open the NACA Profile Generator. Here in the thickness I can put the value I want, for example 12% of the chord. I click OK. Do I want to replace the current marks? Yes. Now the fit is perfect. What we can also notice is that the top point is not at the highest position of the profile. This is because the control point is no longer fixed vertically, but it is still fixed horizontally. Because in the top view, the curves that correspond to the top and bottom point are edited. We can also unedit them. In the list of curves, they are noted bot R and top R. These are the central curves, but on the right side. We right-click on them to unedit them. We notice that this unedits the top R and bot R curves at the same time. Now, the top and bottom points are no longer fixed horizontally. Let's redo the NACA profile generation. We will put 12% of thickness back for example. OK. This time the top control point is at the highest position, with a horizontal tangent. For the bottom point it has kept its initial position, because the lowest point is too close to the edge. Let's start again now, using the tilt field to change the tilt of the profile. I want to rotate it by 2 degrees for example. I put a thickness of 12%. OK. That has rotated the profile. And we see that the bottom control point has been positioned on the lowest point, because it is not too close to the edges. Now we'll see that there is another way to rotate the profile. I hide the guidelines here. I press Ctrl+A to select all the points. Then, Shift plus right-click to go directly to the submenu of the control points, where we find the option, Rotate Selected Points. This allows us to rotate the entire profile. We can directly enter the angle 3 degrees. Knowing that the width is constrained by the outline curves of the foil, it made the profile rotate and then it extended it a little to get the right width. Note that after rotating, the tangent at the apex is no longer vertical. It is better to make it vertical. In particular, if we then want to generate a mold and need to define the top-bottom separation correctly. For the trailing edge too, here, I press Shift to select 2 points. Then, right-click. And I use the Align Selected Point Vertically function to put a vertical trailing edge back. The NACA profile generation function also allows you to import profiles from a .dat or CSV file. For example, profiles that can be downloaded from the airfoiltools.com site here, in CSV format. I click on the Import button to load the file. I reset the angle to 0 to have the profile as it is in the file. I click on OK. Shape 3D loaded the profile, but the adjustment on the guidelines did not work, because the file also contains the camber of the profile, so I have to take the downloaded file and open it with a spreadsheet. Here we see that there is the outer surface, but it also contains the camber line and even the chord. So what we need to do is delete these lines. Then we save. And now I reload the CSV file. Okay, this time the adjustment worked well. Here the trailing edge is completely pinched. In general, we avoid it in production. We can use the trailing edge thickness field here, which we can set for example to 0.05 centimeters. There you go. We have a trailing edge with the desired thickness. We notice that here the adjustment on the markers is not perfect. In this case, what we can do is insert a control point. Right-click, Control Points, Add New Point, and then we import the profile again. Here, we see that the automatic fitting is better. When importing a CSV profile, we can also use the tilt field. I put 2 degrees. There you go, the tilt function worked well. What we have just seen concerns the import of NACA profiles on foils or fins with slices designed horizontally. But we can also use the NACA profile generation function on a symmetric fin. For example, a fin for which the slices have been drawn vertically. If I use the NACA profile generation function here, it will work vertically automatically. There you go. I hope you find this video useful. See you soon.